It's time for Security Now. There's a security technology. Actually, it was originally a software testing technology called browser fuzzing that is now being used by bad guys to find vulnerabilities in browsers. Steve talks about browser fuzzing, what it means, and what's happening next on Security Now.
Netcasts you love.
From people you trust.
This is Twit.
Audio bandwidth for Security Now is provided by Winamp for Android, the ultimate media player for your desktop and Android device, featuring wireless sync. Download it free at winamp.com/Android. Video bandwidth for Security Now is provided by Cachefly at CACHEFLY.com. This is Security Now with Steve Gibson, episode 285, recorded January 26th, 2011. Fuzzy browsers. Security Now is brought to you by Ford. Introducing the all-new 2012 Ford Focus Electric with voice-activated sync and My Ford Touch, featuring gas-free power, zero CO2 emissions, and battery management technology that lets you go the distance. Learn more at focuselectricpower.com. It's time for Security Now, the show that covers your security, your privacy online, and who better to do that than the man at SGGRC. That's his Twitter handle, is grc.com. It's good to talk to you, Steve Gibson.
Leo, great to be with you again, as always, for episode 285. We're going to talk about fuzzy browsers.
Are the browsers fuzzy or something? I mean, are they actually fuzzy?
Well, they're fuzzier than we wish they were. We wish they were really solid and sort of in one piece and not something you would characterize as being fuzzy or furry or flaky. Unfortunately, they are, it turns out. And we're going to talk about the details of browser fuzzing, which is the practice of writing scripts for browsers specifically for the purpose of stressing them and demonstrating where there are unknown problems.
Very interesting.
Turns out it's frighteningly successful. That is, this whole process. So much so that Mozilla has incorporated browser fuzzing into their standard test suite now.
Wow. Well, we'll get to that in a second, but I imagine there's a few security updates on your plate today.
We've got some updates and some news. And speaking of Google, Chromium, or the Google Chrome browser just got itself updated like about a week ago, and they gave their so-called Elite Chromium Security Award to Sergey Glazunov, and he won. Actually, they call it a charity, so he received a charitable contribution for this particular problem that he found. He found a handful of them, but it was $3,133.7, which of course is elite.
Elite. Elite speak.
And they had announced, and we talked about it before in the podcast, that they would reserve this amount for people who found really bad problems because they wanted, or like really difficult to reproduce. I mean, basically, for a security researcher who really earned the, earned the discovery, which he apparently did. This is a critical problem. The Google Chrome people felt with a problem with stale pointers in the speech handling for the Chrome browser. There was this one critical problem, 13 other problems rated high, and 2 that were rated medium. High security problems receive $100, and medium ones receive $500. And actually, Sergey got a handful of them, so he pretty much cleaned up. This was a good month for him, and of course, all of us who are all of the people using Chrome get the benefit of it having fewer problems now than it did before.
Very nice.
I received speaking of SGGRC, through Twitter was the first channel that I saw the notice. Then I saw it elsewhere. Really nice news starting today. Probably not this moment for people who are listening to this live, but I would imagine anyone hearing the podcast later this evening, or like, for example, Thursday the 27th, Facebook has just announced this morning in their blog, their security blog, that they are now offering 100% SSL and HTTPS option.
Oh, that is awesome.
Yes. The URL for that page, I've got a shortened URL, on.fb.me/lowercase I H uppercase Q uppercase Z lowercase IV.
Well, that's easy.
Yeah. Well, I did tweet it. I tweeted it immediately when I saw the news, and gave credit to the guy who sent it to me. And then immediately afterwards, a few other of the main tech channels picked up on it.
That's fantastic. This is in response to Firesheep, obviously.
Exactly. Now, in fairness to Facebook, they responded so quickly after Firesheep that they were already working on this, that I think this was an issue that was already on their radar. We might imagine, though, that they gave it more acceleration, that they put some more effort into it to make it happen. Quoting from this page, they said, quote, "Starting today, we'll provide you with the ability to experience Facebook entirely over HTTPS. You should consider enabling this option if you frequently use Facebook from public internet access points found at coffee shops, airports, libraries, or schools. The option will exist as part of our advanced security features, which you can find in the account security section of the account settings page." I did go there after having someone else respond to my tweet saying, I don't see it. And sure enough, because I've got a Facebook account that I maintain just for exactly this purpose. I'm not active there anymore, Leo, probably than you are. But
I wish I could say that, but I am. I got sucked back in.
Once again.
Yeah.
Anyway, so when I last looked, it wasn't there, but presumably sometime today, on January 26th, 2010, this feature will be added. And I don't have to tell any of our listeners who are Facebook users, check for it over the next few hours or days, turn it on. And the good news is, wherever you are using Facebook, Facebook itself will work to keep you over an HTTPS connection whenever possible, which will, as we know, with threats like Firesheep lurking around, will enhance your privacy and security.
Very good news. They also, I think, have a one-time password, they say.
Well, they mentioned that they're going to, and I got excited about that, and read the rest of the blog and could not find it anywhere. So I think they're talking about getting there. I mean, even the fact that they're talking about that is a good sign. It means that they're beginning to be more serious about security. So, being as big as they are and as significant as they are, that's just good news. I picked up a little bit of news relative to the privacy of employee email. You and I have talked several times, Leo, about how people need to remember that email that you use when you're at work really is not private. You need to consider it as you're using your employer's equipment, your employer's bandwidth and connectivity, so don't consider that private. There was a suit raised when a secretary, I don't know what the exact whole story was, but something about her becoming pregnant shortly after she began her employment. Her employer got upset because presumably, shortly after being hired, she would now need maternity leave or something. But anyway, so there was the lawyers got involved. And what happened was that it went up to an appeals court that ruled, quoting from their ruling, the way they phrased it, the emails sent via company computer under the circumstances of this case were akin to consulting her lawyer in her employer's conference room in a loud voice with the door open, so that any reasonable person would expect that their discussion of her complaints about her employer would be overheard, the court wrote. So that is what the court said relative to the issue, and the issue was attorney-client privilege. At some point, they were trying to take the position that that this could not be used as evidence in the suit because this was attorney-client privilege, protected under attorney-client privilege. And what the appeals court said, and this actually does change some law that or some prior decisions, which is why it got to the appeals court. Previously, there had been some instances where, for whatever reason, attorney-client privilege in a situation like this was held. And in this case, the California appeals court said, nope, exactly as they expressed it.
Cool.
So be aware, if someone has to have a secure email dialogue at work, our users know, that is our listeners know, that you could use, for example, Gmail over HTTPS, which would prevent it from being eavesdropped on so long as your browser has not received a security certificate from your employer that would specifically allow them to filter SSL connections. And again, the way to check that is when you have established an HTTPS connection to Gmail, then check the certificate associated with the page, typically by right-clicking on it and checking properties, and then look at the certificate and see whether whether the chain of certificate authorities goes directly from Google to their root authority and not through something that looks like some third-party SSL eavesdropping monitoring system, in which case you really would not be able to have any kind of communication that would not be eavesdropped by the corporate network. We have talked about net neutrality a lot, and I think that'll be not a huge topic for us because it's a little bit off topic, but I wanted to mention that Verizon is challenging that ruling that we did talk about a few weeks ago, where the FCC took the position that providers could not selectively throttle broadband traffic over their networks, and it's not been clear that the FCC has the authority provided by statutory law that's in place now to do that. And so Verizon is saying the FCC doesn't, which will probably force legislation to be created that gives the FCC or somebody that kind of regulatory power, which it may or may not have, depending on how Verizon's suit comes out. So that's unfortunate.
Yeah.
And speaking of unfortunate, this week, a U.S. congressional panel is holding a hearing to consider reviving the impossible to implement ISP data retention bill, which we have talked about, which would, if it were enacted into law, would require ISPs to retain their customers' internet data for 2 years, which, I mean, anytime hearings are held, I'm sure the ISPs must sit in front of our representatives and senators or whomever is in these meetings, these hearings, and explain to them that it's just a physical impossibility. I mean, of course, immediately and as part of the story, they talked about, well, we want to be able to track down child pornographers. And so, they march out child pornography as the gotcha. It's like, well, you're not for child pornography, are you? Although, in fact, what we know is that, as you and I were discussing actually before we began recording this, Leo, electronic data and electronic privacy seems to be something we're losing very quickly.
Yeah, I hate it when they, conflate child pornography with all of this, because it has nothing to do with it. It's just an easy out,
Right. Right. It's something that everyone is going to vote
who's for that?
To prevent.
Nobody's for
exactly.
that. But that's not what this is about.
Yeah, and the idea that an ISP would need to record 2 years, essentially, we're talking about 2 years of all the traffic through their network. That is, because, of course, their network traffic is the sum of their customers' traffic. And what the people who are pushing the bill want is the ability to go back for a given customer, presumably under warrant, and rummage through everything that person has done for the 2 prior years. So I mean, it just, I mean, if you were Google, sure, you've got a database that's large enough to hold 2 years of all your customers' traffic, but that's nothing that's in place like that is happening now. They're not talking about a real-time tap. They're talking about recording everything for 2 years. So hopefully, much as somebody wants this to happen, saner heads will prevail and say, look, we can't do that.
This is an issue we were talking about before the show began, but at some point I'd love to talk more about these pen register search warrants and how they're being, I think, misused by law enforcement and, in really unconstitutional ways we're being spied upon. And it's just getting worse. And it's because it's electronic, and so it's just deemed somehow less private. It's just appalling.
Yeah, and unfortunately, it does make it easier. It's not like you don't have to go install transmitters in someone's home and car. You just, hopefully, give them a subpoena. And as you're saying, in this case, now subpoenas are no longer even necessary.
Right.
Cisco's annual 2010 security report indicated that cybercrime appears to be migrating from desktops, which, as we know, are becoming increasingly well secured, as are the desktop users, I think, to mobile devices, which are inherently much more vulnerable. So it's probably not a surprise to anyone, but I thought it was interesting that that Cisco is seeing this and noting that this is that our mobile devices, which are becoming increasingly powerful, are becoming magnets for cybercrime. Not good and certainly not surprising.
Yeah.
Now, the big news and interesting news I held for last, and that is that both Mozilla and Google have stirred on the issue of do not track behavior. We talked last week about Giorgio's adding this feature, the do not track, the X-do not track header to NoScript. It had been there actually since a little bit before the beginning of the year, and someone brought it to my attention. I checked my outgoing headers from my browser when I'm using Firefox, and sure enough, those headers were there. Just
of course,
in the last couple...
You have to pay attention to it, right? It doesn't mean anything if somebody doesn't understand it. Yeah.
So, okay, there's two different approaches. Mozilla is introducing, unfortunately, a different do not track header. Yeah.
Why not? Because it's always been good when there have been many, many standards that you have to adhere to. It always makes sense. Yeah.
Exactly. So theirs is called X-tracking-choice. So X-tracking choice, and then you add to it, then it's colon, and then like don't track me or something.
Don't track me, bro.
And I'm sorry. It's tracking preference, and then it's colon do not track.
Right.
So Mozilla's is tracking-preference colon do not track, and it's Giorgio who replied to the Mozilla blog posting, and he said, I'm sure English is not his first language. He said, "Why inventing yet another header X tracking choice rather than reusing the X do not track proposal," which of course is what he adopted with NoScript, which is already implemented in NoScript and AdBlock Plus, and also endorsed by Mozilla. So, who knows why? Many cooks are involved. So what Mozilla is doing, and they recognize that that following this is optional, that is not something that they're mandating. They're just saying we're going to allow a user to turn this on and send this tracking preference header out with all queries. Now, I'm all for it. I like this solution, as I've said many times. In fact, months ago, I've been talking about just adding a header like this, and this has all finally come to pass. It does require voluntary compliance until legislation, which does seem to be rumbling around in the U.S. Congress at this point, legislation would then make obeying and honoring a header like this mandatory. Now, Google has taken a different approach with their Chrome browser. And I've studied what they've done, and I think I understand it, but it's not at all clear. They've got a new extension called Keep My Opt-outs, which is an optional extension that can be added to Chrome. And from what I can see, keep my opt-outs must have the effect, although they didn't say so anywhere, so I can only guess this from the name, of preserving opt-out cookies when they exist. Now, by looking at the blog and following some links, I discovered a site I had not seen before. There is a site called aboutads.info, aboutads.info, where you can go, which is sort of appears to be an advertising industry sort of communal site that's talking about, you know, the nature of tracking and an online behavioral profiling and so forth. What's interesting is that there's another page, aboutads.info/choices. You need to have scripting enabled, and let us when you go there. So when I went, I saw that something wasn't working. In fact, it told me that I had to turn on scripting. So using NoScript, I enabled scripting for that page. And then what happened was it enumerated a large number of known advertisers, and this site it sort of provides a UI that allows people to create opt-out cookies for all of the advertisers that support opt-out cookies. So if we didn't have this, you'd have to go manually to each of these different advertisers and go wiggle around through their websites and figure out how to opt out of each individual advertiser's tracking. What's nice about aboutads.info/choices is it pulls it all together into one place. So I've experimented with it and it works. You're able to just say select all, or like choose the ones that you that don't have a good looking taste for their cookies, and then say, okay, I want opt-out cookies. So what happens is, since only the site which owns the cookie can set the cookie, this script doesn't have the ability to do so. So it must be going out and to each of these different sites using some sort of protocol that they've agreed upon to have each of those sites plant a new opt-out cookie in your browser, which did happen, and I confirmed that it happened. And so that's what aboutads.info/choices does. And if you're using Firefox, you can do it. You can actually use it with any browser that supports scripting. So presumably then, Chrome's new extension, Keep My Opt-outs, does something to prevent them from being lost or deleted. So, for example, if a user flushes all their cookies, this would take priority and it would keep these opt-out cookies in place even if you otherwise cleared all your cookies. Now, the one thing I did note was that doubleclick.net is not listed among all of these advertisers at aboutads.info. There's something like, I don't know, 60 different advertisers, and the script that ran had some problem enumerating some of them, so that I was only able to end up with like 8 or so that I was able to opt out of, and like 39 some were still, they were sort of there but not working yet. Who knows what's going on. But anyway, so aboutads.info/choices is something interesting to look at. Now, so Chrome's not adding a header. I would rather they added a header like Firefox is going to do, the Mozilla guys are doing, like NoScript and Giorgio have already done for us. But, you know, this is something. Microsoft and IE have an entirely different approach. They've got something called Tracking Protection Lists, or TPLs. They've just recently blogged about this. This will be a feature in IE9, which is, in some senses, it's better, and unfortunately, in some other senses, it's not so good. It's better in that it these tracking protection lists are XML files, which are a moderately confusing syntax, unfortunately, but powerful, that allow both enable and disablement for IE to go to a third party. So you have the ability to block third parties, that is, to block IE9's following links to sites that you have blocked. So, and this doesn't, as I understand it, it doesn't even allow IE to go. It's not a matter of it like blocking tracking, it's blocking you going, which I think is fantastic. Websites may object to this. Something like this was going to be in IE8, but Microsoft removed it under pressure from advertisers, and so we didn't get that. So from IE's blog, they say IE9 will offer consumers a new opt-in mechanism called tracking protection to identify and block many forms of undesired tracking. Tracking protection lists will enable consumers to control what third-party site content can track them when they're online. So the reason this is troublesome is that it's not clear where these lists come from. For example, you might go to a site that is able to sense that you are not following its links to its ads, and which scripting at the site could do, in the same way that site is able to say, hey, you've got to turn JavaScript on if you want to use everything we're doing here. So a site could say, you must load this TPL, and they would provide you with their own customized tracking protection list for them, which would get merged in some fashion to provide overrides to your otherwise disabling this. Anyway, you get a sense for this, Leo. I mean, this just sounds like a disaster.
It is.
I mean,
it's worse than I thought, and I thought it was bad.
Yeah. So I don't know how this is going to settle out. I mean, again, it's why I just love the idea of a do not track header. Just have, for users who know they don't want to be tracked, turn that on. I don't even care if it's off by default. You know, just turn it on once and have it be sticky.
Yes.
And so that way the browser is broadcasting with every query it makes. It's saying, do not track me. And then, yes, the argument is, well, but that requires compliance, you know, voluntary compliance. And it's like, yes, until we have legislation in place, which it seems like we're going to have anyway. So the only alternative would be, you know, something like NoScript or cookie management or something like these TPLs, the IE9 tracking protection lists, which also seems like a big snarled nest of mess. So anyway, this is, you know, we're at the beginning of solving a problem which I'm glad the industry is looking at. I'm glad Congress is making noise. I'm so glad the browser vendors. I mean, everybody, this is like, it's not like no one's paying attention to this. Everybody is paying attention to this. Unfortunately, what that means is we've got, you know, 19 different approaches and we haven't reached consensus. But we've been there before. And in fact, we'll be talking about the document object model a little bit later when we talk about browser fuzzing. And boy, that was a disaster in the beginning. And it wasn't until the World Wide Web, the W3 consortium, you know, stepped in and said, okay, here's how we're going to do it, that we finally, you know, got some sanity there. And speaking of lack of sanity, Bruce Schneier blogged just the other day, I think it was yesterday, that a group of students at the Chinese University in Hong Kong have figured out how to store data in bacteria.
Okay.
They have an article, a web page that I have a link in our show notes, which talks about, they say it's massively parallel bacterial data storage system, error-tolerant data encoding and decoding system, recombination module for data encryption, And then this is clearly, again, English is not their first language, not surprisingly. And then they said, ready for the exciting future of biocomputer. So in Bruce's blog, he cites some other people that have looked at the article and scratched their head about what it is that they mean when they say bioencryption, which is the term they've coined. Bruce's comment predictably was, well, I hope they haven't created some sort of new encryption, but rather they're using traditional encryption before they use their bacterial storage to store the encrypted data. So
because you can't encrypt bacteria.
That's
next.
Anyway, that's in the whack. I guess I should put this under errata.
Or just wacky. Wacky would be good.
Wacky, yeah, the wacky category. Yeah, data storage in bacteria. And apparently, Leo, the bacteria can store a lot of data.
Yeah.
So the students are quite excited about this. What I do have in errata is a note about an interesting IPv4 countdown Twitter or whatever that is, @ sign. I guess it's
a Twitter handle. Yeah.
It's a Twitter handle.
Yeah.
So it's at IPv4 countdown, just all run together. And this person is tracking the surprisingly rapid disappearance of IPv4 addresses. So I just thought our listeners, any listeners who are Twitter followers, and I know we've got about 16,000 because they're following me, might get a kick out of adding IPv4 countdown to the handles that they follow. It's very low traffic. It only posts when there's been some loss of IPv4
it looks
address
like it's
space.
every 6 hours roughly.
Yeah, and and it's dropping by millions.
Yeah, every 6 hours, another million down. Wow.
I think it's like 37 million.
No, 29 million.
Ooh, wow, yeah. I guess it was yesterday that I looked.
And
so
another one
right.
just came in, 28 million. That's really interesting. I mean, literally it's every million, but that's roughly every 6 hours.
Yeah.
Wow. So somebody do the math. It ain't good.
Yeah, get your cell phone now.
Yeah.
No, actually, it won't be a problem. Don't hyperventilate. Don't worry about it. In fact, when I posted this, I did tweet about this, and I said, "Don't get upset. I mean, this looks like we're running out of IPs very quickly. What this actually is this is the IANA allocating from their final batch." And we talked about this.
Is this like the last
recently.
Class A?
Well, yes. This is them giving away their blocks to the registries. This is not the registries giving those away. So this is, and we've expected that in the first couple months of 2011, the IANA would discharge the balance of the blocks that it had available to the major registries. Aaron and so forth, all the major NICs.
Is it IANA still, or is it ICANN now? I thought ICANN superseded IANA.
Okay, I think you're right. It's ICANN.
Yeah.
I'm showing my age. So
Jon Postel is no longer with us, I'm sorry to say.
It
used to be, but it wasn't so long ago. There was one guy, Jon Postel at USC, was the guy. That was it.
And all of those early RFCs had his name on it. I mean, when I was reading about, originally reading about the TCP/IP stack, that's where it came from, and email protocol and so forth.
Yep. By the way, Tom Johnson, who does our mail route stuff, worked for John, so he knows John.
Oh, no kidding.
Knew John, yeah. Which is pretty good. A pretty good pedigree for somebody who does email spam fighting.
Yeah.
Yeah. And
I do have a short note from another satisfied Spinrite customer who wrote to Greg/GRC, Greg, of course, being my tech support guy, who said, "I just wanted to send along a message of thanks for a great product. I was able to assist one of my customers in recovering data off a drive that I did not think was recoverable. When I got started, the drive was recognized by the BIOS, but that was about it. And setting the drive up as a slave drive in another machine caused Windows to claim that the drive was not formatted. Check disk failed to run completely. He said Spinrite started out saying that it would take 4,500 hours to repair and recover the drive. So I basically gave up, but decided to let Spinrite run for a while. After 26 hours, Spinrite claimed that it was, well, Spinrite would have been 16% done. Although I guess he's saying claimed because obviously the estimate is coming down rapidly. If it did 16% in 26 hours, and it's not going to be 4,500 hours for the whole drive. That's typically something that does happen when Spinrite
It's slow at first.
Exactly,
Yeah.
runs into trouble immediately. There's nothing Spinrite can do except assume that the drive's condition is going to be what it has seen so far. So it's continually reevaluating its estimate for completion based on the history of what it's seen so far. So at 26 hours, it's claimed to be 16% done. On a whim, writes Peter, I interrupted the process and tried the drive in a slave scenario again. At this point, I was able to recover much of the data. I have since let Spinrite go back to work to finish the process. Even if it takes a few days, you have impressed me and made my customer extremely happy as they had no backup of their data. Thanks again, Peter Elkins at Omnitech Computer Services.
Isn't that
And
nice?
Pete, thank you for the note.
We are going to get to the fuzzy browsers next. Steve Gibson, just a word of warning, you have about a half an hour. Is that enough time to get the fuzzy browsers
I'm watching the
unfuzzed?
clock. Yep,
Thank you.
That'll do it.
And as long as we're talking, let me talk a little bit about our friends at Ford, who do this great new thing called the Ford Electric Focus, coming out in 2012. I already decided it's my next car. I was going to retire the Mustang, but I've been told with no uncertain terms by Lisa, my CEO, that no, you're not retiring it. I'm taking it. You know, it's easy to fight over these great Ford vehicles, especially with the Ford Sync. I love the Sync, true hands-free calling, 911 assist, turn-by-turn directions, all in a great package. And of course, the new 2012 Ford Focus Electric will have Sync with My Ford Touch. It now understands 10,000 commands. You can listen to Pandora and Stitcher from your phone. You can manage your battery. In fact, there's an app for the iPhone and for Android phones that lets you manage the car. You can do things like have the phone say, okay, it's time to charge now because the rates have gone down, things like that. Complete control of everything going on through this incredible My Ford Touch. I'm just so excited. The Ford Focus Electric will charge on a standard 120-volt outlet. You could get in fact, they're going to go through, I think, Best Buy. The Geek Squad can come in and install a 240-volt outlet for you very inexpensively and easily, and then you'll get 3-hour charging. Amazing miles per charge. We don't talk about miles per gallon anymore. Miles per charge, giving you an incredible economy, no CO2 emissions. I can't wait. I just can't wait. I want you to check it out. FocusElectricPower.com. That's the website. FocusElectricPower.com. In fact, I'm very jealous because in about 3 weeks, John C. Dvorak and Paul Thurrott are going to get a test drive one in Madrid. And we'll bring back some videos so you can see it. They're going to Madrid to be among the first, including some of you who won a trip to be some of the first to test drive the new 2012 Ford Focus. FocusElectricPower.com to learn more. Steve Gibson today is talking fuzzy browsers or browser fuzzing. What are we talking about?
We touched on this a couple times in recent weeks because Michael Zalewski, who is a Google security guy, released his what he called cross fuzz, CROSS_FUZZ for browsers. And our listeners will remember that Microsoft tried to lobbied him to not release this at the beginning of 2011, as he had notified them 6 months before he was going to, because he provided them with his tool in June or July of 2010 with the plans to fix or to release this at the beginning of 2011, and telling them that his browser fuzzer found some fuzziness in their browser, and that is in Internet Explorer, and that they should take it seriously and see about fixing the problem. He never heard back from them until the middle of December, shortly before it was deadline time for him to release his browser fuzzer, and they said, hey, wait a minute, now we're able to reproduce the problems, which we weren't able to reproduce before, so we haven't yet had a chance to fix them, so please don't let the world know about these problems, which would happen when you release the fuzzer. However, it turns out that some malware authors, it is strongly believed, independently discovered the problem because looking at Google search history, they were Michael was able to see that there had been some people, I don't remember if it was Russia or China, I think it was in China, that had been doing some search queries that clearly indicated that they knew where this problem was in IE. So it didn't come from him. It was already out in the wild. So he defended his decision to release, notwithstanding Microsoft's rather lame, well, you only gave us 6 months and we didn't take you seriously until 2 weeks before you were going to release this approach. Okay, so what is all this fuzzing? Fuzzing is a software testing technique which essentially sends malformed junk, maybe invalid data, unexpected data, or just pseudo-random data, or all of the above, to the inputs of some sort of interpreter or parser, which is expecting to receive normally good data that it's been designed to receive, specifically for the purpose of seeing whether that software can be destabilized by inputs that it was not designed to handle. Wikipedia tells us that the term fuzz originated for the first time in the fall of 1988 from a class project topic in Professor Barton Miller's graduate University of Wisconsin Advanced Operating System class. The assignment was titled Operating System Utility Program Reliability - the fuzz generator, which is where the term first arose. And so his group of graduate students experimented with this concept of throwing junk at operating system utility program to see if they could break them. And famously, we'll remember that Mark down at EI in Aliso Viejo and EI themselves had a lab set up where they were essentially doing fuzzing of Windows and finding Windows problems in the Windows API by calling functions in Windows, providing it with unexpected data, and then and they had a whole lab set up of machines running, and every so often one would crash. And when that would happen, they would look essentially at the audit trail of what had been sent to cause Windows to crash. And then that would give them clues for looking closely at what it was that their automated, basically noise generator had done to cause the crash. And this is one of the ways that EI has found and uncovered many security problems in the Windows operating system. Now, this is a different approach to normal code testing than has traditionally been done. What normally happens is that there are essentially two parallel coding efforts. First, you have a specification for some software that you want written, and the specification determines, it specifies what it is that the software will do. So you have one team, normally the big team, of coders whose job it is to code that spec, that is to turn that specification into functioning code. You then have normally sort of like the also ran group. They don't get as much glamour. They're not normally held in as high regard, but they're the test suite coders. I would argue that in this day and age, they need as much glory and as much attention as the main product coders. The test suite coders have the job of writing code to test the code that the main code writers write. So they're also working from the same specification, but their job is to essentially create an automated test suite, which once the product coders say, okay, we've read the spec, we've very carefully coded it, our code does what it's supposed to. Well, so how do you know that? Well, a user could play with it and click on things and see. What's much more efficient, though, is if you have, one for one. For every chunk of code that you have a test suite. This is very common for example, in the crypto field, where you have a bunch of known test data, which you encrypt under a given key, and then you know what you should get out if the code is correct. It's the way we verify that cryptographic code is working the way it should. Is we run standard patterns through. So formal test suite development is something that has been done for years. It's sometimes called regression testing. It's something that Microsoft does. Is they have a huge test suite so they want to make sure when they're in Windows rummaging around changing things, they haven't broken something that used to work. Well, the only practical way to do that, you can't just have a ton of users sitting there trying to see if Windows is broken. You need something to exercise Windows. So these exercisers, these test suites, have always been created. But notice that they're being created from the same specification that the coders use, and while the test suite guys can try to find problems, generally they have the same motivation that the test suite coders, that the main product coders do. That is, they're working to show that the code meets the specification, rather than not.
There's a kind of a theory in coding these days, test-driven programming, where you start by writing a test, which fails immediately, and then you write the code to fulfill a test. But it doesn't test for these kinds of things. It tests exactly as you say. I mean, it's a good way to code. You have fewer bugs, but it really only tests to see if the code does what it's supposed to do. It doesn't see if there's a buffer overflow or something like that.
Well, and in fact, in my own history, GRC, a little bit of GRC lore that no one knows, is after Spinrite was up and running and launched, and remember, Leo, I've talked about how the GRC grew to about 23 people, right. I think it was at its largest. Well, I had an R&D department with 4 or 5 programmers, and we were working on something to do next. This was back in the days before caching was even part of the operating system. You had like Windows had Smart Drive, or DOS had Smart Drive that it came with later, and then there was Smart Drive in Windows. There were third-party caching utilities which dramatically sped up the operation of the system. Well, GRC developed one called Propel, and it was, as you might imagine, better than all of the others. The programmer who wrote it was really gifted. I mean, this guy was a spectacular world-class programmer. Unfortunately, Propel, to do what we wanted it to, was very complicated. Well, I was the guy who wrote the tester for it. And so I wrote sort of a generic program which read and wrote in a very pseudo-random, confusing, worst-case data pattern checking kind of thing to and from the disk. The idea would be that if the cache was not there, the program would be writing actually to the hard drive, and it would be creating sectors with pseudo-random data in a, and reading and writing and overlapping, and then when it read it, it would read back the data to verify that it was what it expected to have stored in that sector. The idea being that we needed to verify that inserting this cache in between my program and the hard drive didn't change anything. That is, everything still worked.
Right.
The problem is it would run for a while and crash.
Oh.
That is, there was some problem that introducing Propel, this never shipped, now we know why, never shipped hard drive cache, into the chain caused to fail.
Well, timing is so complicated in hard drives. I mean,
oh my goodness, and actually, for all kinds of reasons, Propel never saw the light of day. I wouldn't say that it was ready. It wasn't like this was the only thing that kept it from being a product. But I had my own experience with this kind of approach, and can vouch for how good it is. So, CrossFuzz. When CrossFuzz was created last summer, it found more than 100 problems in every single browser. No browser was unscathed. The largest number of bugs were identified in Firefox. Michael himself found 10, and then another 50 were found by the Mozilla people when they integrated CrossFuzz into their existing testing platform. The Firefox issues have since largely been addressed. So we're talking like 60 problems that have been found have largely been addressed, but some more obscure and hard to analyze crashes are still occurring. So even today, 6+ months later, if you run CrossFuzz on Firefox, you can kill Firefox.
Really? Wow.
All WebKit-based browsers were brought to their knees with approximately 24 crashes found. The developers were notified in July of last year, 2010, and since then, all relevant patches have been released, yet some very subtle problems persist. And Opera was the other target of CrossFuzz, and their authors were Opera's authors were notified also at the same time in July of 2010, and all of the frequent crashes found by CrossFuzz were fixed in Opera 11. So what is CrossFuzz? How does it work? To understand that, we need to dip a little into a topic we've never covered before, which is the so-called document object model, or the DOM, of browsers. When scripting was first created, that is JavaScript, which was originated by Netscape for the senior Netscape browser at the time. I think might have been 2 or 3, one of the very early Netscape browsers. The idea was they wanted to create scripting on the client side so that a website could download not only a static page, but also some scripting which the client, the browser, would execute, it would interpret in order to make the experience more dynamic for the user. And of course, we know that that's been a mixed blessing because scripting is a real security problem, also a tremendous benefit. The problem is that pages at the time were described by HTML, the so-called hypertext modeling language. And HTML would describe paragraphs and frames and tables and forms and basically all of the content of the web page. But there was no means for a script running on that page to access the elements of the page. For example, to do fancy effects if you rolled your mouse over something, or to be able to notice, like check an input field when you were asking for a credit card number to quickly check to see whether it meets that rule of nines, the way credit cards have a built-in checksum that where you can instantly tell whether there might be a typo, a digit transposition, for example. So there were useful things that you would want to do, but no way for the script running to access the content of that page. So the good news is we're many years forward from those bloody early days where Microsoft had their own approach, which was incompatible with Netscape's, and browsers that were emerging were inventing their own. It wasn't until we finally got some standards imposed and the browsers rather reluctantly over the course of years began to converge on a single unified standard. We have that now called the document object model. And essentially what browser layout engines which receive HTML, they've basically become HTML parsers which parse the incoming HTML into the document object model description. That is, the way things have evolved is that the browsers have become so complex, pages have become so complex, HTML, especially with the addition of CSS, cascading style sheets, have gotten so complex that there is now a sort of a formal tree-structured container for a page. The root of, and when I say it's tree-structured, the root of that tree is the sort of the anchoring document, and it goes by the term document, and then it's the tree form is sort of described through dotted suffixes. So, for example, you'd have document dot and then the name of a form and then dot the name of an input field, and or you might have a table and then rows and columns, essentially forming what's called a namespace where every single element of the page can be described through this dotted textual representation. And that's incredibly powerful, because that then allows scripting, which is running on the page, part of that page, a means for manipulating the page's content. That is, so while the website loads down the initial HTML, the browser layout engine parses the HTML into this document object model description of the page, and then scripting, which is also part of that HTML download, is itself able to access the entire contents of the page, because the HTML describing the page has been translated into this DOM, this document object model, which, because there is this textual namespace representation, allows the scripting to sort of access itself. So what Michael's cross-fuzz algorithm does is it opens two windows containing the same document. And this could be an HTML window, an XHTML, or an SVG, a scalable vector graphic document, which itself is a distressingly complex format. It then, and I'm reading from his description, it crawls the DOM hierarchy of the first document, collecting encountered object references for later reuse. Visited objects and collected references are tagged using an injected property to avoid infinite recursion. A secondary blacklist is used to prevent navigating away or descending into the master window. And then critically, random shuffling and recursion fan-out control are used to ensure good coverage. So what that means is basically he's written a script which explores itself. That is, it explores the window that it's being targeted at to basically build a database of all the contents of the window. He says he repeats the DOM crawl, randomly tweaking encountered object properties by setting them to one of the previously recorded references, or with some random probability to one of a handful of hard-coded, quote, interesting, unquote, values, like a super large value, super small value, -1, 0, +1, So he's got a collection of things that generally cause problems. Then he repeats this crawl of the document object model again, random calling any object methods which he has encountered. So he's also invoking JavaScript on the page that he's basically giving a real hard time to. He calls parameters or the call parameters to those object methods are synthesized using collected references and, again, interesting values, as he noted above. If a method returns an object, its output is subsequently crawled and tweaked in a similar manner. So if calling one of these methods, which is code on the page, if the method returns an object for the page, then he grabs that and crawls that as well. So essentially what he's done is he has built something to just give a seizure to just work the heck out of the code, which is hopefully always going to behave itself, never going to have a problem, and just say, yeah, okay, fine, what you asked for was illegal, or yeah, if that value doesn't make sense, we're going to ignore it. Instead, what often happens is, well, in fact, there is not today a browser which can survive. One way or another, this thing is so horrendous to what it does is it just wrings the code out, and ultimately browsers collapse. So there are problems with this. That is, and there have always been problems with the fuzzing approach, because making something mysteriously break is very different from finding a bug. You haven't found a bug, you've found a symptom.
Yeah,
and
but you've got a foot in the door. Yes,
so you're right. You have, and what he's doing is he's auditing what he does. He uses pseudo randomness, and we know what that means. That means that if you remember the pseudo random seed that you used for driving your pseudo random decisions, then you can. And if you start from a known good fixed condition, you can theoretically exactly reproduce what happened, because it should be deterministic. So it still, though, this is the problem, is that this thing might run for a day, and then the browser finally gives up in defeat. It says, okay, I just can't do this any longer. I can't do it. Now, the problem is, you haven't found the bug. You've just made something die. And for example, we never found the problem with Propel. I mean, this drove Mike, this brilliant coder, to distraction. I mean, it would run and run and run, and then it would have a problem. It's like, oh, this sector didn't match. It's like, well, we don't know why, and we're sorry, but all we can tell you is it didn't work, but we don't know why. So the good news is, there is this insanely aggressive tool that now exists, which the Mozilla guys, to their credit, have incorporated into their own test suite, which kills Firefox, kills Opera, kills Chrome. It kills anything you let loose. It's the destroyer. It has succeeded through the last 6 months of its use in rendering our browsers far more robust than before. That is to say, it takes it a lot longer to kill them than it did before, meaning that all of the problems that sort of were findable have been found, and the coders learned a lot from having this thing, turning this thing loose on their browsers, and they now turn it loose routinely, hoping to see, hoping it takes a long time before it brings the browser to its knees. Ultimately, it does, and that's browser fuzzing.
Are you done? I'm sorry.
Yeah.
My apologies. I took a bite of food, and then all of a sudden you stopped talking. I thought we had so much more to cover. No, that's really interesting stuff, because it is so closely related to the to test suites, but it's just going the extra mile. Really banging on it.
Right. The test suites are, and this is what the advantage of fuzzing is, that although
you're testing it for something else, I guess.
Well, now it's certainly not just throwing noise. I mean, it is. That is to say, a huge amount of code had to be written to implement this technology, which walks this document object model hierarchy.
Is it safe to say it's a stress test?
Oh, it is really. Yes, that's exactly what it is. It is really a stress test. Browsers should be able to pass it. None can. The reason is that this is, if nothing else, it demonstrates how incredibly complex browsers have become in order to do everything that we ask them to do.
Right.
Browsers really are, there's a huge amount of code in them. In order to run JavaScript, they're doing just-in-time compilation of a language into the native machine's tokenized pseudo language, which an interpreter then runs. We take it for granted. We go to a website and it just works.
Right.
But there is a huge amount of stuff now under the covers, and we know for the sake of security that it has to be robust. The problem is it's difficult to make it so.
Right.
So this cross fuzz system, I'm really happy that it exists, because
it's not I guess the point is, it's not just used by bad guys. It would be used by anybody who wanted to test their system, right?
Yes, and in fact, that was the controversial aspect of it, is that Microsoft didn't want it released because IE was being brought down, and if the bad guys, so everybody could run it. The bad guys could run it on IE and use it potentially to find new problems. So now there's a race on, can Microsoft, and here's the problem is, when it brings the browser down, again, I can't emphasize this enough. You really don't know why. You just know that it died. And so it is, and this was why Microsoft couldn't make it fail last July. They didn't wait long enough. Or
give it time.
Give it time. Exactly. And what they found was that it required several different documents to be fuzzed in a row before the final document fuzzing caused the problem. So that meant that you couldn't just fuzz the last document. You had to reproduce the footsteps that Michael had used to get there, which meant that some state somewhere was bleeding across between documents. The point is that as we know, crashes beget malicious attacks. Crashes beget exploits. And so Microsoft was worried that a bad guy would run this and be better than they were at figuring out exactly what it was that the fuzzing found, and then turn that into an exploit that they weren't ready for. So anyway, this thing exists. Browsers today, 6 months after its release, privately to the browser authors, are substantially more robust than they were. And that's why then Michael said, okay, it's 2011. I'm going to, publish this, let it out for the world to play with.
Neat.
And browsers are ready for it, much more so than they were 6 months before,
right,
when it just knocked them all on their butts.
Very interesting stuff. Browser fuzzing. Steve Gibson is at grc.com. That's the place to go for Spinrite, the world's finest hard drive maintenance and recovery utility. Kind of does both. He also has a lot of free stuff there, but you'll also find show notes for this show, transcripts. I wonder how Lane's going to handle the pause. Pause. Oh!
Munch, 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 munch.
Very elegant. Munch, munch. Oh! My mouth is full. You'll also find 16 kilobit versions there for the bandwidth impaired and a whole lot more. Somebody in the chat room said we should someday get a tour of Steve's bookshelf. If you watch on video, you see all those books behind Steve. I bet there's some classics there. And the blinking lights, those are the PDP-8s. So, Steve, thank you. We will see you next week, and we'll do a Q&A. So if you've got a question for Steve, maybe about this subject or anything else we've covered, just go to grc.com/feedback. grc.com/feedback. Steve, see you next time on Security Now.
Security Now.